So yes, welcome. This is lecture number 13 of statics. So we are in the process of solving the problems based on catenary, right? Yes. So if you haven't watched the previous videos, you please watch all the videos and come back to this video. This is problem number 19. So in 17, 18, we are discussing about the problems based on a mass connected with the string, right? Mass connected with the string. So we have solved two problems based on this type. Now we are going to start 19th problem, right? So the 18th problem and 19th problem are similar problems, right? The only difference is here the length is 2L, right? The chain length is 2L. Here the length is L. That's it, right? Here the length is L, right? And that is the only difference. And here H is the length of this portion. Here K is the length of this portion. These two are the only thing you going to change, right? Everything is same as of the previous problem. The previous problem, the length is 2L, here the length is L, and they have given that H is the length of that sag. Here it is K, right? That is these two are the only thing we're going to change, right? Yes. So we will do this problem. Before that, I'll tell you the ongoing courses on Unacademy. You can see Unacademy has produced 7 rankers with top 20, 15 rankers with top 50, and 170 plus Unacademy have cracked it. And there is a new batch for UPSC 21, 22, 23 aspirants, starts on 13th October, right? And also a new batch for quality enhancement and answer writing program starts on 18th October. And this is scheduled for 1 year batch, and these are educators for 1 year batch, and this is scheduled for 2 year batch, and this educators for 2 year batch. And there is also a program called live mentorship program, and you can also avail loan if you want, right? And there is also plus subscription, icon subscription, and you can use my code persona10 for 10% off, right? Yes. So yes, we will start. So this is similar to the 18th problem. The uniform chain of length L and a weight W hangs between two fixed points at the same level, and a weight W dash is attached at the middle point. In the previous problem, P, right? A load P is attached at the lowest point. Here it is W dash, it attached at the middle point. If K be the sag in the middle, prove that pull on either point. That is, we need to show tension at both the point is K by 2L W plus L by 4K W dash plus L by 8K W. This is what we need to show, right? That is, prove that pull on either point, that is tension at A. We need to show, since it is uniform, so tension at A is same as tension at B. So we will show that tension at A is K by 2LW plus L by 4KW dash plus L by 8KW, right? Same as previous problem. The only thing here is, so let me draw the diagram first. Here we have a uniform chain of length L, right? We have a uniform chain of length L. So let us call this point as A. Let us call this point as B, right? It is, the length is L. So therefore, this length will be L by 2, that is up to this. And this length will be L by 2, right? Because the overall length is 2L, right? Yes. Now let me draw the diagram now. A load, a weight W dash is attached at the middle point, right? So we are attaching a weight W dash at the middle point. So my diagram will be like, so we are attaching a weight W dash, right? We are attaching a weight W dash at the middle point. So therefore, when we attach the weight to the lowest point, it will come down, right? So what will be my new catenary? So my new catenary will be like somewhat like this, right? It will be somewhat like this, right? Yes. So it will be like this. It will be like this. Right, this is the new catenary. Now how many the length has increased, this length is increased now, right? So these are the one that we discussed in the previous class, right? So this portion is, this length is increased now, right? So we are having this length is increased after attaching a weight W dash at its middle point, right? So let this length be S, this length be S, right? So overall 2S length is increased after attaching a weight W dash, right? So this is L by 2, this is L by 2, and if you want we can also complete the diagram, right? So we can also complete the diagram. So we will draw directrix and then we will draw tangents at both the points, right? So we will draw directrix, and we will also make a tangent at A. So let us make a tangent at A. So yes, so let us call, okay, let me yes, actually I'm facing some issues with my pen tab. Yes, okay, let me mark this as tangent at A. So this point is A, right? This point is A. I'm making a tangent at A. Let this angle be some psi A, right? Psi A, and there will be another tangent at this point. Let us call this point as E. So we will have one more tangent at E, right? One more tangent at E. So let this angle be psi B, right? Psi B. It can be alpha beta also, but we don't want angle to find the answer for this, right? So let us take this distance as y, right? Let us take this distance as y, and it has given that sag is k. In the previous problem it is h. In the previous problem you can see, it is AB is found to be h, right? Depth of this point below AB is found to be h. That is, this distance is h in the previous problem. Here it is k, right? Here it is k. This distance is k, right? Here it is y. Now what will be this distance? What will be this distance? That is the distance from y to this vertical distance from directrix to this point is y plus k, right? Y plus k. So this is y. So that is from this point to this point it is y, and from this point to this point it is k. So overall it will be y plus k, right? The previous column we have y plus h, y. So here we have k, right? The only thing that we are changing is, in the previous problem, same diagram, same question. Here we have L, here we have L by 2, here we have K, there we have H, right? Yes. So solution. So what we need to tell is, we need to tell that pull on either point of support. A and B are the point of support here. So that is, we need to show tension at A is this, right? So we need to show at either point, but it is uniform. So we will show only at A, right? So we need to show the tension at A. We need to show tension at A. Tension at A is, we need to show this value, right? K by 2L. K by 2L times W plus L times W dash by 4K plus LW divided by 8K, right? Yes. So what is the formula for tension at A? So tension at A is, so same as the previous problem. So tension at A, what is the formula? T is equal to WY is the formula, but here Y is Y plus K. So W times Y plus K, right? This is the tension at A. W times Y plus K, where small w is the weight per unit length, right? Small w is the weight per unit length. Weight per unit length, right? Weight per unit length, right? This is somewhat similar to same problem. The only thing difference is, here we have L by 2, there we have L, right? Yes. Now we will solve by the same method as we did in the previous problem. So what is the weight of capital W? So capital W is the weight of this string AB without attaching a mass at the middle point, right? So it will be W is the weight per unit length. The overall length is what? L, right? So my capital W will be L times small w, right? Call this as equation number 1. So the previous problem we have capital W to be equal to, capital W to be equal to 2L times W, because here the length of the string is 2L, right? Here the length is L, right? Yes. Listen, this is L by 2, this is L by 2. Overall it will be L, right? Yes. Now what is W dash? What is W dash? What is the weight of W dash? Actually, after attaching this portion is increased. So my W dash will be 2S times small w, right? 2S times small w. So call this as equation number 2, right? So from this 2 you can find the value of S, right? So 1 by 2 So this implies W divided by W dash is equal to L times W divided by 2S times W. This 2 will get cancelled. So we have 2S into capital W is equal to L times W dash, right? L times W dash. L times W dash. So that means my S will be now, my S will be L times W dash divided by 2W, right? 2W. This is what the value of S now, right? There we have the length is 2L, here it is only L, right? Yes. Now we need to find the value of Y, right? Let us call this as star. Now in star, we need to find small y, and we can convert small w to capital W from equation number 1, and we can add all these to get the value of this, right? So to find y, again same thing that I'm going to follow, right, as in the previous problem. To find y at E, what is y? Y is same as y, S is same as S, right? Because at E, that vertical distance is, I assume that it is equal to y, and S is S again, right? Because I assumed that distance from lowest point to E, I'm assuming that it is equal to S. So my y square is same as C square plus S square, right? At E, this is a relation between y and S, right? So if you haven't watched the previous video, please watch previous problem, right? Yes. Now at A, what is y? At A, my y is y plus h, and what is S? What is S? Now you can see at A, my vertical distance is y plus k, and what is S? S is the distance from lowest point to A. So from here to here it is S, and from here to here it is L by 2. So it will be S plus L by 2, right? Sorry, it is y plus k, and S is S plus L by 2, right? That's it. Now what is the relation between y and S? Y square is equal to C square plus S square. This implies y plus k whole square is equal to C square plus S square. So S square is S plus L by 2 whole square, right? Let's call this as equation number 4. So same as previous problem, right? The only thing is here in the previous problem we will have S to be equal to S plus L at A. Here it is S plus L by 2, right? So mark this as equation number 5. Now subtract 5 minus 4, you can find y, right? So subtract 5 minus 4. So here you will have y plus k whole square minus y square equal to, here you will have C square plus S plus L by 2 S plus L by 2 whole square minus C square minus S square, right? I'm subtracting 5 minus 4. So when you expand this, you will have y square plus k square plus 2ky minus y square is equal to C square plus, so when you expand this in A plus B whole square formula, so S square plus L square by 4 plus 2S L by 2, right? 2AB. So minus C square minus S square. So these two will get cancelled. These two will get cancelled. So we are left with k square plus 2ky is equal to L square. Sorry, I'm facing issue with pen tab. I don't know why. So this will be L square by 4. L square by 4. This 2 will get cancelled. So we have SL, right? So this means 2ky is equal to L square by 4 minus k square plus SL, right? I'm bringing k square to this side. So we will have y to be equal to L square by 4 minus k square plus SL whole divided by 2k, right? This is what the y value. So let us mark this as equation number 6, right? Same as previous problem. Now what is the tension at A? So from star, what is tension at A? Tension at A is W times y plus k, where small w is the weight per unit length of the chain, right? So this will be W times, so y plus k. So you just add L square by 4 minus k square plus SL divided by 2k plus k, right? Y plus k. So instead of y, I have substituted this formula, right? Yes. Now if you take LCM, we will have small w divided by, so you will have 2k as LCM here. So if you multiply 2k here, we will have 2k square, right? So we will have L square by 4 minus k square plus SL plus k plus 2k square. Actually whole divided by 2k you will have. I'm not writing that, right? So because I've taken 2k outside, so if you want I can also write that in a single step. This will be L square by 4 minus k square plus SL plus 2k square, right? Yes. And we know from 1 capital W is same as L times small w, right? Because L is the length of the chain. So that means small w is same as capital W by L, because we don't have small w in the one that we need to prove, right? So we will change capital small w to capital W by we have 2k, so capital W by L. So this will be L square by 4, so k square plus 2k square is plus k square plus SL, right? Now you replace S, right? So from 3 what is S? S is LW dash by 2W, right? LW dash by 2W. So this is LW dash divided by 2W. So you replace that, you will have W divided by 2KL. So L square by 4 plus k square plus S into W. So S is LW dash by 2W into L, right? SL. Now if you multiply this inside, what we will have is, so when you multiply this with this term, we will have W by 2KL into L square by 4 plus W k square divided by 2KL plus W by 2KL into L square W dash by 2W, right? I'm just multiplying this with all the terms. So this will be, so this L will get cancelled. So we have LW divided by 8k, right? LW by 8k, and here you will have, so what we will have here is, so here 1k and 1k will get cancelled. So we have WK divided by 2L plus, and here you can see this W and W will get cancelled, 1L will get cancelled. So we have L into W dash divided by, so 1L here, W dash divided by 4k, right? 4k. Now this is the one we need to prove, right? So we need to prove this is equal to k by 2L times W. This is same as k by 2L times W. So that is, I'm writing the second term first, k by 2L W plus L by 4k W dash, L by 4k W dash plus L by 8k W, right? So I'm just reordering so that I can prove the one that I need to prove, right? So k by 2L W, so k by 2L W plus plus L by 4k W dash plus L by 8k W. So L by 4k W dash, so plus L by 4k W dash plus L by 8k W. This is the one we need to prove, right? So therefore we have proved that tension at A is this very similar problem, right? So if you have seen 18th problem, the only thing you going to alter is, so here instead of L is the length of this portion, here we have L by 2, right? So that is the only change, and here it is H, there it is K. So when you replace L by 2 and H by K, you will have this answer very easily, right? And 20th problem also similar to 18th and 19th problem, right? So next class we will start 20th problem, right? So yes, thank you. We will see 20th problem in the next class, right? Thank you.